All right, in this video, we're going to talk about division of whole numbers. And in this video, or in this section, we'll discover the meaning of division through various models, explore the inverse relationship between multiplication and division, explore special cases of division by 0 and 1, use division algorithms, including the standard algorithm, and use mental division skills and estimation techniques. All right, so here we're going to talk about models of division, and we do have 3 models of division that are in this section. One of them is the set or the partition model. That's where the set of elements representing the dividend is partitioned into divisor number sets. And let's say we had 18 cookies and want to give an equal number of cookies to each of 3 friends, Bob, Dean, and Charlie. How many should each person receive? Okay. So in this case, we got 18 cookies, and we're going to divide those among 3 of his friends. So in this case here, we do 18 divided by 3, or think of this, 3 times what number gives us 18, which is 6. So each of his friends will receive 6 cookies each. Or we can think of this as using the missing factor model. A divided by B would be means that there is going to be a unique number C such that B times whatever C is will have to be equal to A. So if each friend receives C number of cookies, then the 3 friends will receive 3 times C, or 18 cookies. That means 3 times what number C would give us 18. And in this case, it'll be 6. And then the repeated subtraction model is where the divisor is continually subtracted from the dividend until only the remainder is left. So in this case here, suppose we have 18 cookies, want to package them in cookie boxes that hold 6 cookies each. How many boxes are needed? Well, we can reason that if 1 box is filled, then that means 18 minus 6 will be 12, meaning we have 12 cookies left. Fill up another box with 6, then 12 minus 6 means that there are 6 cookies left. And then put the final 6 cookies in the 3rd box, that means we have no cookies left. So that means we have 3 boxes of 6 cookies each. So that's how we use repeated subtraction. Now, notice when I was reading this, there are some terms that you do need to know. Now I'm going to write this as this, 6 divided by 18, that gives you 3. The 18 in this case is what we call the dividend. Now, what we're dividing by, which is a 6, that would be your divisor. And the answer that we get after the division is called the quotient. Okay, so it's the dividend divided by the divisor gives you the quotient. All right, now on the next page is the definition of division, which is just what I got through talking about here. For any whole numbers, A and B, with B not equaling to 0, A divided by B would give us C if and only if C is a unique whole number such that B times C does give us A. So in this case, the number A, that's the dividend, the B is your divisor, and the C is your quotient. And we can also write it like this, either as A over B, or like this here, where the B is on the outside and then you have the A underneath the division symbol. Now for the division algorithm. The division algorithm is this: if you're given any whole numbers A and B with B not equaling to 0, there exist unique whole numbers Q, which is the quotient, and R, which is your remainder, such that A is equal to B times Q plus R. And R is a number that is at least 0, but less than B, which is, of course, your divisor, because the remainder has to be less than your divisor. Now, when A is divided by B and the remainder is 0, we can say that A is divisible by B, or that B is a divisor of A, or that B divides A. Here's an example. Let's say if 123 is divided by a number and the remainder is 13, what are the possible divisors? And in this case, let's say 123 is divided by B. Then from that division algorithm, it has to be this: 123 is equal to sum B, which is your divisor, times Q, which is the quotient, plus the remainder of 13. And the B has to be greater than 13, because in this case, your remainder cannot be bigger than your divisor. So B is your divisor. It must be greater than 13. So from that definition of subtraction, if we subtract 13 on both sides to get B times Q by itself, it will be equal to 123 minus 13, or 110. So B times Q must be equal to 110. Now here we're going to be looking for two numbers whose product is 110. And one of the numbers has to be greater than 13. And this table does show all the possible whole number divisors, whole numbers whose product is 10. Okay. Now later on in this course, we'll be talking about divisors and then listing factors here in this case. Now, we can see that 110, 55, and 22 are the only possible values of B because they're greater than 13. So your possible divisors are going to be either 22, 55, or 110. Now let's talk about division by 0 and by 1. Here we're going to let n be any non-zero whole number. Then, if we take n, divide that by 0, that's going to be undefined. Because you have to think of this, there is no number multiplied by 0 that's going to give us n. So like, let's say 17 divided by 0, that's undefined, of course, because there's no number. You have to think of this: 0 times what number, which I'm going to call n, must equal to 17. There isn't any, because if I pick any n, if I multiply by 0, it's going to give me 0. It's never going to give me 17. So that's not going to happen. So there is no number for that. So n divided by 0 is undefined. Or any number divided by 0 is undefined. Now, in this case, 0 divided by any number n, with the exception of 0, is 0. So if I do 0 divided by 17, that would be equal to 0. And 0 divided by 0 is undefined. What do I mean by that? That means 0 times what number I choose has to give us 0. And there are infinitely many numbers that I can choose for n. So let's say n is 28. Well, 28 times 0 is 0. What about 1 million? 1 million times 0 is 0. What about 38? 38 times 0 is 0. So 0 divided by 0 in this case is undefined. Right. On the next page deals with how multiplication and division are related as inverse operations. Okay. Now, this actually all of the operations. So in this case here, if you look at addition and subtraction, those are inverse operations. And also multiplication and division, they are also inverse operations. And going this way, the operations are repeated. When you multiply, when you do repeated addition, that's actually multiplication. And when you do repeated subtraction, that's obviously going to be division. And let's take a look at this first homework example. Similar to the one in my math lab. For each of the following, find whole numbers to make the statement true, if possible. Like in part A, if we have 9 divided by 3, well, there is a whole number where 3 times what number that gives us 9? That's, of course, going to be 3. In part B, what number divided by 33 would give us 0? Okay, well, we can think of pretty much has to be 0, because 0 divided by any non-zero number would give us 0. And then 49 divided by what number would give us 47? Or think of 7 times what number gives us 49, which would be 7. Okay. All right, take a look at another homework example like this one. Write the complete fact family for 45 divided by 5 equals to 9. Okay, so we have to choose all 4 facts in this family where 45 divided by 5 is equal to 9. Well, A would not work because that's 45 times 5. That won't give us 9. This one, 45 divided by 9, will give us 5. So that would be one that we can use. But 9 divided by 5 does not give us 45. This one, 45 divided by 5 would give us 9. That would work. 5 divided by 45 does not give us 9, so we can eliminate that. Also, we can eliminate the 45 times 9. That doesn't give us 5. Now for this one, 9 times 5 does give us 45. And 5 times 9 gives us 45. We can use that. 9 times 45 does not give us 5. And also 5 divided by 9 doesn't give us 45. Nor does 9 divided by 45 gives us 5, and 5 times 45 does not give us 9. So the ones that I have checked are the 4 facts for this family of 45 divided by 5 equals 9. All right, now let's go to properties of exponents. This one is the quotient rule for exponents here. And I did talk about this briefly in the last video for section 3.4. If A, M, and N are natural numbers with M being greater than N, then A divided by N, M divided by A to the M divided by A to the N would be equal to A to the M minus N. In other words, when you divide powers of the same base, you bring over the base and then you subtract your exponents. That's what that means. Okay. So let's say A to the 10th divided by A to the 4th. I'm dividing powers of the same base, so I bring over that common base of 8 and subtract 10 minus 4. Now I'll end up with 8 to the 6. All right. Let's look at some division algorithms, starting with the base 10 blocks to develop the standard algorithm. So let's say we want to do 726 divided by 6. And in this case, we're going to model 726 using 7 flats 2 longs, 6 unit pieces. That's 726. Now we're going to determine how many sets of 6 flats or hundreds there are in this representation. And as you can see here, outlined in red circle, in a red circle, there's only going to be 1 set of 6 flats. And we're going to be left with 1 flat, 2 longs, and 6 unit pieces left over. Now that 1 flat, we're going to convert that into 10 longs, as you can see. That 1 flat was converted into 10 longs. And now we're going to determine how many sets of longs, which will be your 10s, are there in 12 longs and 6 units. And by here, in groups of 6, we got 2 sets of 6 longs with 6 units left over. And then finally we'll determine how many 6 units or 1s there are. If we group these, we only got 1 group of 6 unit pieces. 1 set of 6 flats, 2 sets of 6 longs, 1 set of 6 units. That's 1, 2, 1, or 121. And we do have a remainder of 0. So that's how we use base 10 blocks to divide. Okay. Next, we'll look at the partial quotients algorithm. And that's the use of repeated subtraction by subtracting multiples of 10 or 100 based on the divisors. So like for 726 divided by 6, we can use this method along with a more efficient method. Okay. So here we do 726 divided by 6. And here they subtracted 600. That's like 106s. So 600 from 726 will give you 126. All right, and then they subtracted 60. That's 10 sixes. And that'll leave you with 66. They subtracted another 10 sixes, which is 60. That'll leave you with 6. And then minus 6, which is only 1 6, will leave you with 0. So 100, 10, 10, and 1 added together means that there are 121 sixes. Or we can say 726 divided by 6, which is 121. Okay. And here you can see this in a more shorter, efficient method on the right side. Okay. So they use 26s, which is going to be 120. All right, next is the scaffolding algorithm. Scaffolding takes the numbers on the right and places them on the top. The scaffolding shows the place value, which is important to understanding the standard algorithm. So here on the left side, they use that scaffolding approach. Okay, because they thought of 600 as, of course, 100, and then the 20, and the 1 to get 121. And this right here is the traditional standard algorithm here. If we divide 6 into 7, that goes 1 time. 1 times 6 will be 6. 6 from the 7 would be 1. You bring down the 2. Repeat that until your remainder is less than your divisor. So in this case, 6 goes into 12 2 times. 2 times 6 is 12. 12 from the 12 would be 0, but you bring down the 6. And then 6 goes into 6 1 time. 1 times 6 will be 6. Subtract 6 from 6, you'll be left with 0. So that's how we use the standard algorithm here. All right, now let's look at this homework example number 3. Okay, now for the sake of time, what I will do here is do only part A. And for those of you who are in my classroom, I'll do parts B and C. I'll post those on Canvas as well. This is 657 divided by 19. Because it says perform each of the following divisions using both the repeated subtraction and standard algorithm. Let's see here. I'm going to subtract multiples of 19. And I know this, if I do 19 times 10, that will be 190. So I'm going to subtract 190, if I can, from the 657. I'll have 467 left over. So I have like 19 times 10. And I'll subtract another 190, which is still 19 times 10. That would be 277. And I can also subtract another 190. That's another 19 times 10. This will be 87. Okay. Let's see what I can do here. If I do another repeat subtraction, I'm going to do minus 19, which is like 19 times 1. Subtract 19, that will be 68. Subtract another 19. 68 minus 19 will be 49. And that 19 is like 19 times 1. Subtract 19 from 49, that will be 30. I'm running out of space here. This is like 19 times 1. And then for the 30, I'll subtract another 19. That would leave me with 11. So that's 19 times 1. Okay. Now notice that this remainder of 11 is less than the divisor 19. All right. So I'm going to add these numbers together, and that will tell me what my quotient is. Okay. So this one I'm going to add 10 plus 10 plus 10 plus 1 plus 1 plus 1 plus another 1. That's 30 plus 1, 2, 3, 4. That would be 34. So the quotient is 34, and my remainder there will be 11. So 657 divided by 19 will be 34 with the remainder of 11. Okay, so this is using the repeated subtraction. All right, now using the standard algorithm is usually this. If I divide 19 into 65, that would have to go 3 times. 3 times 19 would be 57. Subtract 57 from 65, you'll be left with 8. Then bring down the 7. And then 19 into 87 will go 4 times. 4 times 19 will be 76. Subtract 76 from 87, you will get 11. And here 11 is less than the divisor of 19. So that means this will be 34 with a remainder of 11. 34 with a remainder of 11. Now I'm just only going to do part A. Part B and part C, I will work those out and post those solutions on Canvas for you to refer to. Okay. All right, let's go to mental mathematics, which is dealing with division, mental mathematics. Breaking up the dividend is one way to do division mentally. like 5,648 divided by 8. Here we break up the dividend into parts, like the 56 is broken up and then from the 48. And then we divide both parts by 8. That 56 will be like 5,600 divided by 8, that would be 700. And then 48 divided by 8 will be 6. And then add 700 to 6, you'll get 706. So 5648 divided by 8 would be 706. Second method is using compatible numbers like 105 divided by 3. I will break 105 up by finding numbers that are divisible by 3 whose sum is 105. That'll be 90 plus 15. 90 is divisible by 3 and 15 is divisible by 3 as well. And they add up to 105. So if I do 90 divided by 3, that'll be 30. 15 divided by 3 will be 5. Add 30 and 5 together, you'll get 35. And here's another example of this, like 232 divided by 8. Here you look for numbers that are divisible by 8, but the difference is 32. Here 232, I know 240 is divisible by 8. Let's use that. But to get to 232, we have to subtract 8. And then divide both of the parts by 8. 240 divided by 8 will be 30. 8 divided by 8 will be 1. And then we subtract 30 minus 1, you'll get 29. So that's another method of using compatible numbers to divide whole numbers. Okay. Now, the only estimation technique for that for division is using compatible numbers, like 3,752 divided by 6. Well, 3752 is close to 3,600. Let's use that. Divide that by 6, you'll get 600. So 3752 divided by 6 will be approximately 600. Okay. So pretty much you have to use some type of number that's a multiple of 6 that's close to 3752 in this case. We have to use 3,600. All right, now on the next page deals with order of operations. And in this case here, when you have no parentheses present, multiplications and divisions are performed before additions and subtractions. Okay, the multiplications and divisions are performed in the order they occur, and then additions and subtractions are performed in the order they occur. You might remember this particular phrase of remembering the order of operations. Please excuse my dear Aunt Sally. Okay. So here the P is the parentheses. You do what's in the print. You do the operations that are in the parentheses first, and then multiplication. Please excuse my dear Aunt Sally. Got in the wrong order. The E is for your exponents. You do your exponents after your parentheses. If no parentheses are there, then you do your exponents first. Then all multiplications and divisions are performed in order from left to right. And all additions and subtractions are also done in order from left to right. So in other words, if subtraction comes before addition, you do the subtraction first, because you have to do the operations of multiplying and dividing in order from left to right, and adding and subtracting in order from left to right. Okay. So let's look at this homework example number 4. Let's say we want to place parentheses if needed to make each of the following equations true. So in this case here for part A, we got 4 plus 3 times 4. And that's equal to 28. And I want to put the parentheses in the proper place so that I would get 28 as an answer. And in this case, I need to put the parentheses around the 4 plus 3. So that 4 plus 3 would give me 7. 7 times 4 would give me 28. Okay. Now in part B, we got 12 divided by 4 plus 1. And I want that to be equal to 4. Well, let's think about this. Since 12 divided by 4, since I'm required to do multiplication and division in order from left to right, I'll have 12 divided by 4, that's 3, and 3 plus 1 will give me 4. So in this case, no parentheses are needed. Okay, and that's because order of operations tell me to do division first and then the addition. Like part C, 5 plus 4 plus 9 divided by 3 needs to be equal to 6. And in this case, I will need parentheses. And I'm going to need it around the 5 plus 4 plus 9. Because 5 plus 4 plus 9, that would give me 18. Then 18 divided by the 3 would give me 6. Now, if I was to leave the parentheses off, what's going to happen here is I'm going to have to do 9 divided by 3 first, which is 3. And then 5 plus 4 plus 3 will not give me 6. So I need parentheses around the 5 plus 4 plus 9. And then part D, we got 5 plus 6 divided by 2 plus 4. And I want that to give me 12 as the final answer. Okay. Let's see. If I do the division first, which is 6 divided by 2, that would be 3. 5 plus 3 would be 8. 8 plus 4 will give me 12. So for this problem, no parentheses will be needed. No parentheses will be needed. All right, let's look at another homework example here. Students were divided into 10 teams with 12 on each team. Later the same day, students were divided into teams with 8 on each team. How many teams were there then? Okay, 10 teams with 12 on each team. So if I multiply 10 times 12, that's going to be 120. So there were 120 students altogether. Later that day, those same 120 students were divided into teams of 8 on each team. So we're going to take 8, divide that into 120. Well, 8 goes into 12 one time. 1 times 8 would be 8. And then subtract 8 from 12, that will be 4. Bring the 0 down. 8 goes into 40 5 times. 8 times 5 will be 40 with 0 remainder. So now there were 15 teams. Okay, with the students divided into teams of 8. So now you have 15 teams. And the last example on the final page is Dave purchased a $31,000 life insurance policy at the price of, excuse me, at the price of $32 per $100 of coverage. If he pays the premium quarterly, how much is each installment? All right, so now $1,000 of coverage, which is $31,000, and then we have $31,000 purchase. Let's divide 31,000 by 1,000. And this can be done mentally by crossing out zeros in the numerator and the denominator. You'll be left with 31 over 1, which is just 31. So that's like 31 units at a price of $32 for each $1,000 of coverage. 31 times 32 would be, forgive me for using the calculator, 31 times 32 would be $992. So that premium is $992, but he pays it quarterly. Now let's think of the word quarterly. That means the first 3 months, the second 3 months, the third 3 months, and the last 3 months. So that means that there are 4 installments. 4 installments. So we're going to divide 4 into 992. And in this case, if I divide 4 into 9, that's going to go 2 times. 2 times 4 will be 8. Subtract 8 from 9, that will be 1. Bring down the 9. 4 goes into 19 4 times. 4 times 4 will be 16. 16 from 19 will be 3. Bring down the 2. 4 goes into 32 8 times. 4 times 8 is 32. You have a 0 remainder. Okay. So in this case here, each installment will be $248. So Dave pays the premium quarterly. That means you have to pay 4 equal installments of $248. All right, so this does conclude this video in section 3.5, dealing with division of whole numbers. All right, so feel free to email me if you have any questions about any of the problems presented in this video, or if you have questions about the homework that's in my math lab for this section.